ilalaban kahit kanino. Oo, simple lang ako at malabo mong magtipuhan, kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Okay, last time we discussed about the SP3 hybridization for methane. Okay, so at this point, it's not just methane that has an SP3 hybrids. Okay, so other than that, methane belongs to the class called alkanes. So we have methane, and it followed by the ethane molecule, and then propane, and so on. So all alkanes, all molecules or all compounds that belong to alkanes has an SP3 hybridization. However, for methane, it only consists of 4 SP3 CH bonds, while for ethane and propane and so on, they have actually an SP3 CH bonds and at the same time with an SP3 CC bond. Okay, it's because if you write the chemical formula for ethane, we have C2H6. Okay, so this is the general formula for ethane. So we have 2 carbons on it. Okay, so we would expect that it has an sp3 CC bond. Okay, it's not just an sp3 CH bonds, but rather it also has an sp3 CC bond. Okay, so this is now the representation for ethane. So ethane can be drawn or can be represented on this electron dot structure. Okay, and we have a line band structure and its condensed structural formula. Okay, so condensed formula, I mean. So you notice that in ethane we have a CC bond. Okay, so what is the general formula? It's C2H6, 2 carbons, and 6 hydrogens. Okay, don't forget that 1 carbon should have only 4 bonds. Okay, you should not put 5 bonds to carbon or 6 bonds to carbon. Should only consist of 4 bonds. Okay, so this is now the sp3 representation for this carbon, and the other sp3 representation for the another carbon. Okay, so the sp3 CC bond would be on this side. Okay, if this sp3 carbon will bond to another sp3 carbon, then there is a bonding that will occur to both of the sp3C here and the sp3 carbon there. And this is what we call an sp3 sigma bond. Okay, so sigma bond is basically, it is a single bond. Okay, the overlapping bonds or the overlapping of orbitals of between the C here and the other C. Okay, so there is an overlapping orbitals which result to a sigma bond, which is an sp3 sigma bond, because both of these carbon are actually sp3 carbon. So this is now the general structure of the ethane. It's just like your tetrahedral methane. So tetrahedral methane, but it has a greater band angle because of this CC bond. Okay, the sp3 sigma bond. Okay, since this sp3 or CC bond has electrons on it, or there are more electrons on it, so therefore a very strong repulsion would be coming from this bond and the bond of your CH. So the tendency would have a greater bonds here. Okay, so you notice that the bonds between your CH in the methane is only 109.5 degrees, but But because of this, the presence of the CC bond, it will tend to repel the bond angle here because of electron cloud on this bonds here, the sigma bond. Okay, so it has a greater electron cloud because of the overlapping of the orbitals of the C here and the other C there. Okay, so the maximum bond length for the CC would now have 154 picometer. So it's a lot greater than the CH bond. So it's because of repulsion. Okay, so this is now its general structure, and you have a ball and stick model for this. Okay, so always remember, don't forget how to write it on a three-dimensional, the solid line, the wedge line, and the dash line. Okay, so we have here a problem. Draw the line band structure of propane, predict the value of each bond angle, and predict the overall shape of the molecule. Okay, so propane is the next alkane after ethane. Okay, so you have methane, ethane, and propane. So how do we write the line band structure? So given its condensed formula, so this is actually a condensed formula for propane, we can directly get the line band structure. Okay, so we have C. There are actually 3 carbons total. Okay, and both of these carbons are actually bonded to each other. Okay, because as we all know, for ethane we have a CC bond. Okay, so therefore in propane we have also CC bond, but we have 2 CC bond. We have one here and the other one is there. Okay, so you notice that on the first carbon it has actually 3 hydrogen. That is very correct. Okay, so because this first carbon would have 3 bonds remaining, because the other bond is actually bonded to the carbon, so a total of 4 bonds. For the second carbon, you have only 2 hydrogens. That is correct, okay? Because the 2 bonds are actually bonded to the carbon, so it should have only 2 bonds left for the hydrogen. And the last one would have 3 hydrogen because your carbon has only 3 bonds remaining. Okay, so this is now how you're gonna write the line bond structure. Okay, you just copy the remaining hydrogens. Remaining hydrogens. Okay. Okay, then you're done. Okay. The next question is predict the value of each bond angle and predict the overall shape of the molecule. So you would expect that we have here a sigma bond here and also another sigma bond there. So there are a lot of electron pair repulsion that is actually happening here. There is an electron repulsion here and also an electron repulsion there. Okay, so we would expect that the value of each bond angle would have, or propane would have a greater than 109.5, since we have a lot of repulsion here. So there's actually an electron cloud here and electron cloud there because of the sigma bond. Okay, so it will tend to repel this portion here, so that it would have a greater than 109.5 degrees. So the band angle should have greater than 109.5 degrees. More or less the same with your ethane. Could have been I could have a 111 or greater than that. Okay, so that's all.